So topics of this discussion will be how Airflow works and why it should use it and what is asynchronous operator. So the brief agenda that I have set up for this topic, like initially I will talk about like what is Airflow workflow, like how you can write some simple workflow in Airflow. Then how the architecture of Airflow look like Airflow has lots of big components, so how those components talk to each other. And then I will talk about the asynchronous operator. So this is like one of the mechanism of like how you can save your resources by using your DAG. Then I'll talk about like why you should consider using the Airflow. Also, I'll talk about some use cases. So yeah, let's get started. Hi, I'm Pankaj. I'm currently full-time software engineer at Astronomer. I also maintain one of the repository at Astronomer. It's called astronomer-provider, which has asynchronous operator and sensor. I also do contribute in Apache Airflow. And it's been not long since I started the Airflow, so it's been just 5.5 months. I have been learning Airflow. So yeah, that's all about me. So let's move to the next slide. So what is Airflow? So first question, like when we start anything learning, so first question from about it, like what is it, what we can do from it. So I thought a lot about like definition. I can read some good definition, but ultimately I end up with like taking up this screenshot from Airflow site. So which is I would say a gold definition. So if you go through the definition, it says programmatically you can author, schedule, and monitor the workflow. So it talks about mainly three terms. You can author workflow, and you can schedule, and you can monitor. So programmatically, author means you do not need some kind of JSON or XML where you can't code. You can just write configuration. But the Airflow has you can write code actually. Your DAG or your workflow would be like a code. So benefit of code is like you can do whatever you want. So if some library available, you can use that. So there is lots of flexibility available in case of code. So scheduling means like you can decide like how you want to run your DAG. So Airflow has inbuilt scheduler so that you can use it. Monitoring means so I would say like Airflow has very great UI. So you can like see lots of things in the UI and it's very powerful, truly powerful. And also if you want to like pass your log at some different places, so that also is configurable. So okay, so last slide, like last slides, I discussed about the Airflow, I mean workflow. So in term of Airflow, like a DAG is a workflow. So you basically call a DAG as a workflow. So let's talk about like what is DAG. So in Airflow, DAG is just a Python file. So it's Python file which contains a DAG object. So DAG is basically directed acyclic graph. So if you know a little bit about the graph theory, so directed acyclic graph means there is no loop allowed there. So there can't be self loop or you can't make circle there. So this is basically a directed graph, which makes sense here. DAG is basically you can say like it is a kind of like template of writing your workflow, and so it's basically contain operator and sensors. Okay. And in the task usually, I mean, so it's up to you. I mean, if you are a author of operator, whatever you want, you can do. But usually it performs a single unit of task. For example, let's say you are writing an operator to insert some data into some SQL. So that kind of thing, single unit of task. There is a relationship between task in a DAG. So it means that so DAG is a basically graph. So where node is your task or sensor. So operator or sensor is your basically node of the graph. So edges are basically a relationship. So there can be like upstream, downstream tasks. And Airflow execute this task based on the relationship. that you have defined in your DAG. Okay, so enough of like definition how what is DAG. So let's take it like one example how it's look. So it's just so what I want to do. So basically, uh, I just want to show you like one workflow. So in this workflow, I want to do a very simple thing. So what I want to do, I want to read my history of browser, okay, and then I want to write that history into CSV file. Then I'll push that into GCS, and then I'll move that from GCS to BigQuery. And my basically my history has two things. One is like what I have browsed, and another is date. So I want to run this DAG daily.
What does
So
GCS is?
GCS is like a bucket in Google Cloud.
Oh, okay.
So
Hey Pankaj, can you just come a little bit closer to the mic?
right?
Yes.
Yeah, that's okay. Yes, sure. So what it is doing basically it's taking my browser data and pushing it into at the end in BigQuery. So which will have what first thing is like date, and another thing is like what I have searched in my browser. So once this is a kind of like workflow. So you can do couple of things in that, like what I am once I am on my computer, what I'm searching, those stuff you can do like ML or some machine learning, you can do anything like that. So how this workflow look in basically Airflow. So you can see there is one DAG object, and it has one DAG ID. So this DAG ID should be unique across your DAG folder. And the schedule interval I have gave it daily, means it will run daily. And start date is 1/1/2022. So it will start from the 1st of January 2022. And yeah, that's all. And it has 3 tasks for 3 units of work that I wanted to do. So in first task, you can see that like it's a Python operator. So where I'm calling one function get history, which is defined on top. So where I am reading my history and I'm doing little bit transformation to that and saving that into the one file, CSV file. In second task, I'm reading that file and pushing that file into the GCS. Okay. In third task, what I'm doing basically loading from GCS to BigQuery. And the relationship I defined in the last one. So you can see some tiny error. So that basically pointing the relationship. So it can be forward arrow, backward arrow. So it's depending on like you want to define relationship downstream or upstream. So this is simple at one time. This can do the job that I just showed you in the previous one. So this is how a diagram. Okay, so I want to discuss a little bit about some concept of the Airflow. So if you see a DAG, so it's just about the writing. Template. It's just a template for writing your workflow. So when actually your DAG started running, or you can say it's scheduled, so your DAG is converted into the diagram. And operator is a kind of like a template for writing your task. So once like you put your task into the DAG, then it's become task. So it's hard to digest, but this is how it is. In task is basically converted into the task instance when it's actually started execution, or when you need to run it, then you need to convert it into the task instance. Okay, so having said that, so how does actually, this looks a bit complex, like you have just one Python file, and based on the some definition that you are giving there, it's doing lots of things. So how does this complex system work? So I'd like to give you some brief, like how does it work. So I basically first visited into Airflow concept site, and I found these architecture data. So this is actually good. It explains lots about the airflow. So you can see that there is one user interface which give us a sense that it's some kind of UI and you can see something there. And then you have web server. So basically UI is calling the web server, and then you can see you have one component scheduler, one component executor, which looks somehow closely attached with scheduler. And then we have one tab folder, we have one worker, and then basically multiple worker, and then the database. So this is the high level diagram of like Airflow architecture. So this is good, but it's at least give you a sense like what are the major components that Airflow has, but still, I mean, so to understand like what actually going inside, so this is not enough. So let's break it a bit. Uh, so I'll start with the DAG parsing. So how does it happen? DAG parsing. Uh, so basically, first thing like when you write your DAG, you put your DAG into the DAG folder, and then the DAG parser basically pick those DAG and they try to do some computation on that. So Airflow has basically one module called DAG processing. So which responsibility to like turning your Python file into the DAG object. So basically what it does, you can see it as a like some loop which is keep running and which I mean keep tracking up your DAG file. If there is anything change or anything new will come, then it will start taking memory. So it has two major components. One is like the DAG file processor manager and DAG file processor. So again, this run, I mean by default inside scheduler only. So once you start your scheduler, it basically started start by itself. But since this is if you want, you can run it as a different process also. So this is configurable. And if you see some like in diagram like how does it work, so it's basically keep track of your DAG file you have put in your DAG folder, and once it find any new file, it pick up that, and then it try to do some processing, some serialization of that DAG file, and write that DAG file into your the metadata. On the theoretical part, so it I mean so there is responsibility that DAG processor manager class does, and there is some responsibility to the DAG file processor. So DAG file manager is basically keep track of the new file, and it's basically queue basically your file path, and then pass those path to the DAG file processor. And DAG file processor basically load the model and check like this is valid DAG and do everything about now. And then it's also log the status, like how much time it took to load this DAG file. Okay, so what is scheduler? So scheduler in Airflow is just a like sub process. It's a Python sub process. So its job is to like monitoring your DAG. So once your DAG is passed and it is in your DB, so it keep monitoring it and kind of like keep track of like what is next to run. Like what are the DAG run and DAG or task which satisfied the criteria to running it. So it's basically its job is you can say like based on the parameter that you define, it will create your diagram and task instance object. Once their dependency is basically satisfied, so that they can pass this to the next like executor. So it's a highly available. What does it mean? It's like you can have as many of as instance of scheduler you want, so you can horizontally scale it. So this is just like you can say some architecture diagram which is explaining like how does this happen. So here you can see like I have created executor in some different block, but it's just so that things will look easy, but actually executor run inside scheduler one. So you can see that scheduler basically scheduler is talking to database and then it's trying to compute like what it can run, and pass those to the basically executor. What executor does. So Airflow has, I mean, so if you see the scheduler, so scheduler is a kind of like very attached to the Airflow, but executor has multiple options. So you can use like salary executor, you can use Kubernetes executor, and means that you have options. So there is a nice interface like how executor will talk to the scheduler, but after onward, like whatever you want you can do with your executor, so it's just and up to you. It's depend on the author of the executor. So executor in nutshell, basically once scheduler decided like what task instance it want to run, so scheduler just make the decision, I want to run this, but the executor take charge of running this. Means that executor take those task instance, it decide, it figure out the resources like where it can run it and how it can run it. So that is the basically executor responsibility. So so it's take charge of running your task instance. So there are basically three type of executor on a high level, you can say. One is a local executor. So local executor basically run your task inside scheduler process only. And so I mean I have already mentioned that uh, executor is attached to scheduler, is run inside scheduler only. But in case of local executor, even your tasks run inside the scheduler process. But things is different in case of the remote executor. So remote executor has a concept of like work, concept of like worker pool. So it's run your task on the worker node. So there are two major you can see type of uh, executor, remote executor, which is available for the Airflow. One is Celery and Kubernetes. We will talk a bit about it later in this talk. And also there is one hybrid executor. Means you can run even uh, I mean multiple executor, you can say. So like Celery Kubernetes. So you can run Celery as well as Kubernetes executor together if you want. So I'll talk a bit about high briefly like how Celery Kubernetes and hybrid work. So this is how Celery executor works. So you have scheduler. So scheduler basically has decided what task instance want to run. Then give that task instance to executor. Executor basically give that to the queue. So you know like Celery is a kind of like written on top of some message queue. So some message broker. So it can be Redis or RabbitMQ or something else. So executor take those task instance and pass those task instance to your queue, and now it's worker responsibility to pick those task instance and then run it on the worker node. So it's I mean and also like worker is also highly available, so you can scale it horizontally. So you can have like as many workers as you want. So so once it's execute and then it's give back the result. So it's give back the result. uh this is how basically the Celery executor works. uh, so Kubernetes one. So there is, I mean, it's a bit different than how the Celery one. So Kubernetes basically run its task in a complete isolation. So once your scheduler is ready to give task instance to the executor pick those task instance, and now it's a spin up pod, and then your task basically run in that pod, inside that pod. So it's get a complete isolation, you can say, but it's come up with some trade-off. So trade-off here is like it takes some time. So you are spinning the cluster, you have cluster already, you are spinning the pod, and that will take some time to come up. And so it's give you a good isolation, but it come with cost of latency. So there will be latency. So, and once your task execution is done, it will write result to the DB, and then it will, your task will be basically marked success or fail depending on how you will.
Pankaj, I had a question here if I may ask. So in the previous slide, wherein you were mentioning about the local executor, you had mentioned that.
Can we take?
Yeah, sure. Sure. Questions after now.
Okay, so now we know, like now we know basically how executor does, like what is executor responsibility, and how the back processing works. So let's look at the task life cycle. So once your task is, once like passing is done, it has yet not scheduled, then task is literally like no status. So it has no status. Now once scheduler, based on your parameter, like when it should start, so decided to schedule it, so it can have that time like uh three cases. So it can be scheduled, means we are good to go for this task. Another can be like removed. So maybe like scheduler is deciding something, meanwhile you remove that task. So maybe that in that case it is a removed status, so it does not make sense to move the task instance to execute. And another is like upper stem fail. So let's say some task will depend on some other task. So if parent task fail, so it makes sense to fail, although it's depend on the author of the tag, so they can decide to do what they want to do. And once it is scheduled, then next step as a like executor take those tasks. And here you can see queue. It means it is a kind of like a salary kind of, you can say salary executor kind of thing, executing your task. So your team will pick up those task instance, and now it will be worker responsibility to run these tasks. So worker will start running those tasks, and there can be two conditions. One is like it succeeded, in that case your task is done. Another is like it failed. So it failed, so there can be two conditions. So either you can mark it as a fail, or it's, if you want to like retry, so you can give some retry also. In case of retry, it will again schedule the task, and then it will repeat the process. Another can be happen like in case of like sensor. So you can run it as in like rescheduling mode. So which means that uh, your task is not completed, but you want to save some resources. So what you can do, you can say that okay, this task might take longer time, so I'll free up the worker and I'll go back and sleep for some time. So in that case, it will free up the worker and it will came came back, and then after some time it will again reschedule based on the time that you have decided. So web server. So basically, Airflow web server is a Flask server. So its main responsibility is to be served to the UI. So what it does, basically read your metadata DB. So metadata DB has like information about like your tag, your connection, your logs, those all information. So it's basically take those information and depend on like what UI want, so pass those information. So you can say it is a kind of like interface between your database and your UI. So it serve as a kind of like in between them. So its main purpose is to just like serving the UI. So this is the one screenshot that I took from the African Airflow documentation. So once you open the web server, so homepage will look like something like this. So you can see here, we have 26 tag, 10 is active, 16 is paused, and then you can also see some colors here, like 10 means this task or this tag has succeeded, and you can see light green, which means this is still running, and those options you can see. And also on the top you can see some like admin it like admin blocks. So there you can see connection and those all things. You can browse. You can go there and see your diagram. So what is status of the diagram and some parameters, some metadata. So metadata DB. So metadata DB basically work as a brain of Airflow. So it is a kind of like central thing in the Airflow. So far, I mean, you must have realized like everything talk to database. Your database. So your web server is talking to database. Your scheduler is talking to database. Your tag parser is talking to database. And your also executor, or you can say worker is somehow. So it's a kind of like brain of your application. So it store the all the information like your variables, your connections, your role permission, and also the your tag status, present run, past run. So you can even see even individual tasks. So you should tag run or task run, like what is their status and log that you want. Under the hood, Airflow uses SQL Alchemy as a ORM. So theoretically again, you can basically configure any database backend which SQL Alchemy support. So theoretically that should work, but in practical, so there are three database. I mean more than three, but three usually people use. So one is like SQLite, so that is not recommended for the production, but if you want to set up it on your local and you want to do some try, so that is a good point to start. And so other two is like MySQL and the Postgres. But prefer, I mean, people prefer to use the Postgres, but both MySQL and Postgres are supported for the products. So you can use previous. Okay. So now let's look at the architecture diagram we I mean which we look at the start of this talk. So now this makes sense. Like now we know like executor is inside scheduler and how it speaks the task and then it passes to the worker nodes and also your tag parser which is not in the this diagram, but this is also closely attached to the scheduler unless we want to configure it manually to run activities. You can have web servers and user interface basically getting served from the web server, and everything else is talking to the database. So database is central to this application, and you can so this is a kind of like a problem also. So so it's a single point value. So if your database is down, so since there's only one instance, so you can't do anything. But also I mean positive thing is like it's a single point of coordination also. So it's easy to to basically talk to one places, like everybody is talking to one place. So design wise this is like you can say also like easy and or more you can say like clean design kind of thing. Okay, so one thing I forgot to mention, like hybrid executor. So how does that work? So hybrid executor basically, so as I mentioned, you can run like multiple like celery and Kubernetes executor. So both is running. So how does it? I mean, it get decided that which executor to pick and your task instance is ready to run. So if you are using multiple executor, then basically you define the queue that you want to use. So based on your queue, you can decide you want to use the Kubernetes one or the Celery one, and so why do we need the hybrid one? So let's consider this scenario where you want to run the large number of task instance, but some of them are really needed to be run in the isolation. So none of them individually, neither in the celery nor the Kubernetes one is good fit here, since celery does not run in complete isolation, and Kubernetes one took some time, since it will spin up your pod, then it will run your task instance inside that. So so here, like, uh, you can say that Kubernetes celery is a good fit execution in hybrid mode. So what you can do, you can, the task instance that you want to run in the isolation, there you can define your queue as a Kubernetes, and rest thing will be run as a your celery executor. So you can get both a kind of like isolation where you want, and also the speed where you want. So what is asynchronous operator instance? So first thing, like, what is operator and what is sensor? Why do you need two different things? So so operator is a, you can say, like, is an entity which does something. I mean, which does some action, you can say, like inserting data into some table, or you can say moving some data from one place to other place. So it is doing some kind of action. In the other, in the sensor, so what sensor does basically, it does not, does a kind of like nothing. It just wait for something to happen. So for example, let's say you want a file, you want to wait for a file to land in S3 bucket. So sensor, using sensor will be a good fit there. So it will do nothing, it will just keep waiting that until your file will land there. So it just waits, sensor is just wait. And but on in the operator, it does, usually it does some action, but always it depend on the author what they want. Okay, so why do we need actually uh, asynchronous operator? So first thing, uh, we discuss like how our task run. So our scheduler basically decided what they want to run, then they pass that to the executor. Executor pass that to the queue, and then what? So finally, if you see the where, let's say you want to trigger some Spark job which take maybe 6 hours to run. So where that 6 hour is going. So scheduler will not take much time, because its responsibility is to just decide like what it want to run. It will pass ultimately execution will happen on worker. So most of the time going on the worker. So if you see the time, so your bottleneck here is worker. So and Airflow has a concept of like worker pool. So you can't run like infinite number of tasks. So in the Airflow worker. So because it depend on the worker pool size, you can run that many things on the at a time. So since your one job is running, which is taking 6 hours, so your one worker slot is a kind of like block for that time. And okay, so that's a block, that is fine. But the problem here is your task is not running inside Airflow. It's running on some external system, maybe on a Spark or some EMR cluster, or somewhere else. So it just like your worker node is just waiting to complete your task, and it's a kind of like blocking your worker pool. So it's doing nothing, but it's a kind of like it's just blocking the other tasks to not. So asynchronous uh, asynchronous operator and sensor basically allow to suspend itself. So in case of asynchronous operator, what it does, it will submit your task and then suspend itself. So when it suspends itself, it will free up the worker slot so that the other task can run, and you can go and keep checking the status. Once your status is fail at or pass, based on that, it can give you the final result, but it will not block your uh, worker. So how does, I mean, asynchronous operator and sensor basically you can achieve, how you can write? So in Airflow, I think 2.0. So trigger got released. So you write your asynchronous operating sensor on top of the trigger framework. So I'll talk a bit about it, like what is trigger. So trigger are basically a small, you can say, small kind of like Python code which is asynchronous, and and inside Airflow basically trigger. So run a kind of like asynchronous event loop, and also the Airflow introduce a state, default state. So once your task is like pause its execution, its state become the default, and it's release the worker slot and submitted information to the trigger so that it can pick your this particular trigger. Here is like one example for the trigger. So what it's basically doing. Uh, so when you are writing basically trigger, so you have to write two methods. One is serialize, another is run. So serialize method is basically helpful for the trigger so that it can later serialize it, and it can again run the your run method. And run method is basically it just like keep polling the status, keep polling the status, and until you execute the terminal state. Once you have terminal state, it's basically trigger one events. So this event will be held, and then your the parents process will catch it, and that's how you can write a simple trigger. So this trigger just taking one parameter moment and deciding that once your moment is greater than this time, current time, then keep running. Otherwise, once that time is passes, just events. I mean, trigger it one, just yield one event. What we need one. So how you can use your trigger? So you can use it in you can use it in your operator or your sensor. So since if you notice this trigger, so this is doing nothing. This is just waiting. For here moment is time, so it is just waiting for some time. So it's doing nothing. So that's why it's writing a sensor here makes sense. So this sensor what is doing, you can see that in execute method. So it's doing self.data, which means that as soon as you call this method, your trigger will be default. It will stop and basically pause the execution, free up the worker slot, and then your control will go to your trigger delta time delta trigger, and which you just saw. And once your trigger will get fired, so you can say like one parameter is method, so which name is like execute complete, and you can see implementation of that is in down. So once your trigger will fire, your control will come to execute complete. Since we do not have anything to do here, so we are just returning it in the parking task. So I mean, we also did some benchmark internally, like how this asynchronous operator is improving the resource saving. So we basically try to run some 1,000 task, you can say, task instances, and we tried like how the worker slot is occupied in case of asynchronous and synchronous sensor. So here is the data that we have. So you can see that. So basically, what in first column we are doing, basically we are sleeping for some time, and then again polling the status. And the second column, like when the sync version is running, so how much time your workers slot was actually blocked. So when sleep time was 30 seconds, your workers slot was, I mean, blocked for around the 67408, and you can see when asynchronous we were using, so it has improved by almost 71%. And as I mean, as your task will take more time, what will happen? This improvement will keep increasing, because as task will take more time, your worker slot will be more busy, and 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 so it will improve if you use asynchronous operator. So this is really one mechanism to save some dollar if you want. So please do consider using it. So so here you can see the just the graph, like how it's behaving. So for synchronous and asynchronous, and how you basically what the slot will be. So for synchronous, it is almost constant, you can see, and is for asynchronous, as I mean it's I mean it kind of like exponentially increasing. Uh, you you basically slot. Okay, uh, so okay, so basically, if you want to I mean, we at astronomer also maintain this repository. So astronomer-provider. So we have implemented lots of operator and this sensor, which is asynchronous in nature, uh, which is available in this repository. And this is the free open source. So if you want to use it, you can use it, or if you want to basically I mean, you can use it, you can contribute it here if you want, or you maybe you, you may be like check if something is not available. So please file ticket. I'm one of the maintainer of this repo, so I'll highly appreciate if you can just file some ticket, or anything, any activities that can be helpful to you, that will also help to us in improving our repo. So this is almost 50 asynchronous operator and sensor. So if you want to use, I mean, I'll highly recommend you to basically switch from synchronous to asynchronous. If your task take lots of time, it will save lots of your work as well. So okay, I'll talk a bit about the use cases, some use cases. So okay, so I basically opened the Airflow site and tried to, initially when I was running the Airflow. So and I try to see like what are the use cases, how people are using it, because learning use cases is one of the good way to basically you understand like what are the beauty of product, what we can do from it. So you can see this big name who are using this product, and they are doing some cool thing around it. But actually, I don't want to talk any of these use cases. I want to talk one unpopular use cases, which is a quite unpopular but very interesting to me. Which called Visa. So by anyone know Visa project here? Okay, so Visa is a project which started in 2016. So this is for world largest democracy. So it is a data platform for world largest democracy, that is India, of course, and it is a called like national data platform for our country. And what it does basically, so it's a provide. I mean, so these are basically provide you an interface for our MPs, MLAs, and also government official to monitor the national level scheme that is going, their progress, and those all things. So this is how you can, I mean, define it, like what is value of visa. So it was a, I'll just read for you. So visa is a crucial step toward good governance, through which we will be able to monitor everything centrally. It will enable us to effectively monitor every village of the country. So I mean, this is a very important project, and it basically keep track of 42 scheme, and the scheme is like Swachh Bharat mission. You can see Manrega, Pradhan Mantri Awas Yojana. Those kind of, these are the very big projects. So if you see the demography of our countries. So it's a very, I mean, very different with lots of diversities. If you see some healthcare data, so in some state it is in a different format. In some state it is completely different format. So very complex data. I mean, no doubt, very complex data, and it's a 42 national scheme for, I mean, this much big country and this much diversity. So what they do basically, they use Airflow for their ETL tool. So they have like, so for all these projects. So what happened? All the things that were happening around project, like progress or some delay or something like that. So like what's happening, status of those projects, so what's going on around it. So it get written in some software, which is of course not same. It is completely different in one state and other state. So they extract those data and then do some transformation on top of those data and write those data into warehouse. From there, I mean, our government official and our MPs and MLA can able to like monitor centrally like how the progress is going on. And this is almost a like for one financial year, this is almost a 2 lakh crore budget. So it is monitoring it. So you can see the scale of this program. Uh, this is very important. Okay, so I think by now you should have some idea like how airflow is important, what all things that you can do with the airflow. Uh, but okay, I'll try to again explain like why you should definitely consider using it, not using it. So even not using it, then at least evaluating it if you are writing some data pipeline because of this reason. So it is a open source, we all know, but it is just not open source. It is a part of prestigious Apache Foundation that has project like Spark. And and if you see some stats, so it has more than 26k star, which is project has more than 10k or plus more than 2k contributor. So especially the open source project give me a confident because I can go into the project. I mean, there is nothing hidden there. I can go, I can look at the code base, I can modify the code base, I can do anything, whatever I want. And and also I do not have to take care of everything. So it is highly possible that someone else will find bug before I will find, and it will even get fixed. So people are basically working for you also for free. So I mean, this is open source under Apache Foundation and highly active, I will say. If you see I mean, it's a kind of like a storm. So its popularity is increasing day by day. Also, I find, I mean, initially, I am also initial learner of the Apache Airflow. As I mentioned, in just 5 months, I have been learning this. So, great community, I have personally find it. So, I mean, you go post your question on Slack, probably you'll get answer immediately or in a day. GitHub, I mean, so I have very great experience in the repo. So even I file PR, I immediately get a response from someone. So very great community. Airflow Summit is like one of the big summits. So there are more than 8,000 people join in it, one talk. So I would say like great community around it. So great community means project is highly active. It's not like a date. So most probably, I mean, whatever decision is taken, it is in open. And I mean, if you feel something is not right, you can challenge it. So this is open for everybody. So you can challenge it. You can share your ideas, improvement, everything. All things are acceptable there and highly extensible. So this is a kind of like my personal favorite. If you want to write one operator, you do not have to care about how scheduler works, how executor works. You just have to write one Python file or maybe two Python file. That would be sufficient, and you do not need to know any underlying architecture. How does it work? Still, you'll be able to write your operator or sensor. Yeah, and also like you can see that the executor, even executor is available in multiple flavors. So that is also a kind of extensible one area of extension. You can say if you want to write your scheduler, you can do it. Pretty much you can do it. It's possible, and you can see we already have multiple options. And
May I come in? Yes, please come in.
and it is highly scalable. So at least your web server, your scheduler, your worker, and your triggerer is like highly is basically highly scalable. So you can keep as many as distance you want. So you can basically uh, you can basically scale this horizontally. So all four components which is like a highly available. And I would say it is also a richer it has like rich feature. So as I mentioned earlier, very powerful, literally powerful event. You can see even each and I mean small things like how your one task distance log it will do. You can do some kind of like backfilling if you want. And there is 75 plus integration available. So which means that's around this much a provider available. So this much of services you can connect with if you want. You need anything. Awesome CLI. So it has definitely powerful CLI. So very powerful CLI. Airflow also provides a Helm chart and Docker image. So if you want to do some Docker deployment, so you can use the image also that they provide. And loss mode, I mean, list will keep growing. So loss mode since it's very active, very active. Also, interesting thing is like there are managed services around the Airflow. So not all the, I mean, you can see lots of project is open source, but not all project is like fortunate enough to have the managed services. But Airflow is the one of them. There, for that you can get the managed services. So at least currently 3 big players you can see there who are actually making money out of this project. So you can see Astronomer. So you can use the Astro Cloud if you want. So they provide the managed services for Airflow. You can use AWS. So you might have heard about the MAWA. So AWS provides the MAWA that you can use if you want to use AWS services. Google also had Google Cloud project that you can use for GCP. So these are 3 major managed services which is available around the Airflow. So if you don't have time, you don't want to manage yourself, there are people who can help you and manage for you. That's all I wanted to talk about.
Thank you, Mr. Pankaj.
I had a question around local executor. So it mentioned that in local executor, all the tasks are executed inside the scheduler itself, right? But you have workers separately. So scheduler would put those tasks in the workers itself. So scheduler would get idle that time, right? Like scheduler would put all the tasks in the workers, and then the scheduler would get idle for that particular time. Or it will keep polling the workers for that complete process until those.
Scheduler does not do any sort of polling.
Correct. So those all those tasks are being executed inside the workers. Right?
So you are talking about the local executor.
Correct.
So in local executor, your tasks run locally only. So in scheduler process only.
Okay.
So we all did a self-intro.
Oh, okay. So I'm Adrit Agarwal, and I'm working with JP Morgan Chase as a software developer. So I just found the LinkedIn post last night, and
nice. Thank you very much. DM Cloudruns. We have someone from JPMC.
So because I'm working on this particular project on Airflow, so I thought to attend this.
So can you say your name again, please?
Adrit Agarwal. AADRIT. I had a question. Can you see the type of executor being used on the UI or UI API?
Can you come again?
Can you see the type of executor being used for the Airflow infra? On, I mean, either on the Airflow UI or via the API. Like, what kind of executor is it using? Like when you right, you told the
Mohammed, I think the meeting got muted. We cannot hear.
So, for example, let's say if you want to run the salary executor, then you have to take care of about like a message queue. So you need some message broken.
You have a different question. No, my question was that like if I already have an Airflow environment, right? So everything is configured for me by someone, like someone from the team. So can I determine what kind of executor that environment is using, like either by the UI or by the API?
Yeah, you can examine that.
There is an API for it. So whatever the executor using, whether salary or any other. So there is an department I had written one for that.
So there is a way you can do. I
can show it up after the conference. I bring my laptop.
So pretty much you can do.
Also, you can look into the configuration.
Guys, can you talk a bit louder so that the folks on Zoom can also hear what you are saying?
Okay, so
Yes, please come closer.
I'll repeat the question. So the question was like, so Airflow is already configured. So can
That's the mic. But anyway, if you're closer to the table,
can I click the what executor it is running? So this was the question. So yes, you can check.
So you can check it in configuration as well as you have REST API to check this. And I think I would like to answer your question as well. So can you repeat your question once?
So the question was in the presentation was mentioned that in local executor, all the tasks are executed within the scheduler itself, scheduler process itself. Right. But my question was that scheduler process is one entity and I have workers that are separate, right? Yeah. So the scheduler has a responsibility of putting those tasks into the workers. Correct. So when I say they are being executed inside the scheduler itself, what do I mean? Like, aren't these two separate things?
Yeah, they're two separate things. So I think you're talking about local executor, and local executor is not to be used in production. Okay. This is just to try out stuff, and So when you say local executor, what it means that it will just simply, instead of delegating this task to any worker node, it just execute that then and there. But if you have configured it for high availability, that's when you start to use worker nodes. So then in that mode, in that scheduler, then scheduler will actually start to delegate those to different worker nodes, and it is controlled by what executor you are using. So local is for just trying out, and if you have a salary executor, that would be for something like this.
But even in local, you'll be putting it to delegating it to workers.
No, you don't need
no.
Okay. That will be processed in the scheduler itself. But it's just one function that just executes.
Okay, so let's suppose I have a task running. I have multiple tags and I have a task running, and suppose that that particular task takes 5 minutes.
Yeah.
So my scheduler won't do anything else.
No, that's why I'm saying that it is not meant for production use. If you want to use it in higher availability mode or with any other executor, you use different executors for that are specifically for processing large amount of tasks.
So worker doesn't come in picture when I'm talking about local and sequential executor.
Yes.
In salary executor, there was a PPT where you show the queue actually. The executor will just put the task in the queue and the worker will pick it up. So that queue, where is it actually? Like, is it like some file system or some memory storage?
So you have to maintain that queue. So I think you can configure multiple queues. I'm aware of RabbitMQ, which I've personally used.
Okay.
So you can use RabbitMQ, Redis, or any queue.
So the salary executor will simply say, okay, this is a task to be executed. It doesn't map the task to any of the workers. It's the worker responsibility based on their availability of the worker slot.
So yeah, you just scheduler will just put in the task in the queue, and it's workers' job to actually pick it from the queue. Okay. So and workers are agnostic of what task actually you're using. So it can be any task.
It can pick it. And how do you define the slot actually? when you say slot is split, is it like the thread kind of thing?
Worker slots you're talking about.
Worker slot.
So yeah, you can define it from the UI also, from configuration also. So you can define it. So it is configurable, like how many slot you want.
So the worker slot means so the question is like, I think is it like a thread? The slots are threads, different what are the different threads, or how is it different process?
Can I come closer to the table so people on the call can hear
you can
what
have
questions
like,
are being asked?
So you are talking about like it's a thread. It is highly available, means you can have even multiple machines.
Okay, no. What does the slot mean now?
Yeah, so this is a kind of like a kind of like thread, you can say.
So is it like, for example, you talk about the async operators, basically freed up the slot meant for any sensor which is simply waiting actually. So that slot is so basically I'm just asking maybe a dumb question. So instead of going with this async operator, can people simply increase the slot? Because the more slot you have, the more workers
So
task.
the problem is like your resources is limited, your memory is limited. Okay, so how much memory you can use? So that's why you can't keep increasing it. So after some time it will be like bottom. So it will not make sense.
I had one more question. So in this entity executor, you showed there was a queue, right? But the queue was not there in the Kubernetes executor. In your slide at least. So that the queue was missing. So there was direct connection to the gates environment. So how do we control for like bottlenecks here? Like does it create a new pod every time you schedule a task?
So in case of Kubernetes, so each task run inside a separate pod. So that's why it's give you a kind of like complete isolation.
Okay, but that will also have some limit, right? Like the number of pods will be limited, like at one point of time. Like suppose I have a group administration with 3 nodes, right? I can have only so many pods running at a time and delete for bottlenecks. So but then there was no queue behind that environment in your like presentation. So then how do we control for that bottleneck if it arises? Like if there's so many tasks running in parallel.
So as I mentioned, like scheduler is also available, high available. Okay. So if you need, you can horizontally scale your scheduler.
Okay. Workers you mean like on the
no, scheduler is different than worker. So so scheduler is like make a decision like what I want to run.
Yes.
Worker is the place where actual execution happens.
Yeah, that is what I'm talking about. Like that is getting bottlenecked because of many tasks running.
So as I mentioned, like your scheduler as well as worker is highly available. Okay. So you can scale it horizontally as well.
I have a question. So in production scale, and this is a real time scenario I'll explain. So in production scale, when you have a multi-node or when you scale horizontally with multiple workers and you have more than one masters and situation where you have more schedulers, let's say we have 2 schedulers, how do we tackle that the job is split between the schedulers and there's no duplicate data or duplicate diagrams for the same application? Is there a way? I've seen this multiple times, and that's the reason I raised this. So if you scale it, let's say you have 20 odd workers for Airflow. Okay, you have 2 masters, 2 schedulers. Whenever a job is scheduled, it gets scheduled from one of the schedulers. So if you have an automated process, it can get scheduled on either of them. What is the chance that how do we avoid duplicate execution of data or duplicate write of data?
Okay, so basically they take care of it. So you know, like there is a status sync for a task. So it is in schedule mode or some other mode. So and there is single point of coordination. I believe I haven't used this scenario, but I believe there is single point of coordination, which is your database, where we maintain the status. So I think that would take care of it. So yeah.
So